Hi ladies, Mr. O'Sullivan. Today we're going to be doing lesson 8-4, the volume of a prism and a pyramid. Today's learning target is that I can apply my knowledge of area to calculate the volume of a 3D prism or a pyramid. So before we even go into some math problems, we actually have to know some vocabulary. So prism. A prism is simply a polyhedron where the bases are congruent and parallel, and you're going to be hearing us name these shapes by their base. So for instance, their base can be a triangle, a square. Well, that looks like a rectangle. This looks more like a square. And we can even have like a circular base if you want to think about it in some situations. A right prism is when the edges of the sides are perpendicular to the base. So that means they're creating a right angle, so you might have to do some Pythagorean theorem. So if you look at this one, I have a triangular prism because my base is a triangle. If you look here, I have a quadrangular prism, or a rectangular solid, because my base is a rectangle. Here I have a hexagonal prism because my base is a hexagon. And then I have a pentagonal prism because my base is a pentagon. An oblique prism is simply a prism with bases that are not aligned directly above one another. It's tilted or slanted. An oblique prism is one whose sides do not form 90-degree angles with the bases. So they're just sort of slanted prisms. Okay? So volume of a prism. So to find the volume of a prism, our formula that we have to memorize is volume equals B times H. Here's the issue. The B stands for not just your base, it stands for the area of your base. And the area of your base depends on the shape you're dealing with. And then you multiply it by the height of your prism, not the height of your base. So one thing I do is I rewrite my formula as volume equals BH. And I just draw like a little arrow to say that I mean area of base. Okay. So if I look at this image right here, this has a triangular base. So if I look at this, it's a triangular base. And if I want to find the volume of it, I know my volume is equal to BH. And we just said that the B stands for the area of our base. And if our base is a triangle, we know the area formula for a triangle is base times height divided by 2. So then I would multiply it by my height. And in this case, I'm talking about this height of my prism. If I look at this example, I have a rectangle as my base. And again, we know volume equals BH. And if we remember, we know our rectangle area formula is what? Very good. It's length times width or base times height. So if I want to, I can say volume equals length times width times my height. And then in this example, I have a square as my base. So if I wanted to, we know our volume formula is equal to BH, where B is the area of our base. And we know that the area formula of a base is just going to be our side length squared, because we know all the sides are congruent. So we would just say volume equals side squared times our height. And remember, this is the height that we're talking about, this height right here. So let's go into some practice. Find the volume of a prism if the base is a square with sides measuring 7 and an altitude of 3. So if I look at this problem, I know my base is a square, so that's something that stands out to me. I know my sides are 7 and an altitude of 3. That's a fancy way of saying height. So if I look, my square is this gray region right here. So I know my side lengths are 7, 7, 7. And I know my volume formula is equal to BH. And we know that B is the area of our base. So if we know that, we remember that our area formula for a square is side squared. And then I now multiply by my height. If you look, what is the side length of our square? Very good, it's 7. So my volume is equal to 7 squared times my height of 3. And when I type that into my calculator, what do I get? Very good, I get 147 units cubed. The reason why I say units cubed is because volume is measured in units cubed. Number 2, find the volume of a prism that has parallelograms as its bases. The base of a parallelogram is 9 and the height is 5.6. The height of the prism is 1.5 feet. So the thing is, we don't really need to draw this, but it's very hard to draw this type of stuff. That's why I just go off the formula. We know our volume formula is BH, where B is the area of our base. And our base is a parallelogram. So what's the area formula for a parallelogram? Very good, it's base times height or length times width. So if you think about it, I'm really doing volume equals base times height times my height of my prism. And if you look, the base of the parallelogram is 9 and the height is 5.6. So I can do volume equals 9 times 5.6 times the height of my prism, which is 1.5. Oh wait, this is a typo. I meant to change this. 1.5 feet. 1 second. I meant to put an 18 here. So now I'm going to put an 18 in for my height of my prism. And now I just multiply them all together. When I multiply them all together, I get 907.2 inches cubed. Now let's look at pyramids. A pyramid is simply a solid figure with a base that is a polygon and a lateral faces that are triangles. A regular pyramid is a pyramid whose base is a regular polygon and lateral faces are congruent isosceles triangles. A right pyramid has the apex directly above the center of the base, so our apex is the tip of our pyramid and our base is the bottom. An oblique pyramid, the apex is not directly above the center of the base. So if you look, it's not directly above, it's sort of jutted out a little. And here we have a triangular pyramid, and then here we have a quadrilateral pyramid and so forth. So it goes to show that our pyramids can vary in shape. And again, our volume formula is still BH, but this time we multiply it by 1/3. So volume equals 1/3 BH, where B is the area of your base. So let's look at question number 1. Question number 1 says, find the volume of a pyramid with a square base where the area of the base is 16.4 inches squared and the height of the pyramid is 16.7 inches. Round your answer to the nearest tenth of a cubic inch. So if I look at this example, I have a pyramid. It has a square base. The area of the base is 16.4 inches squared, and the height of the pyramid is 16.7 inches. So we know our volume of a pyramid formula is volume equals 1/3 BH, where B is the area of your base. If you look, the question's already telling us the area of our base. We know it's 16.4. And now we want our height, which is the height of our pyramid, and in this case, we know our height is 16.7. Now we just multiply those all together. When you multiply those all together, you get 91.2933 repeating. And if I want to round this to the nearest tenth, how would I round this to the nearest tenth? Very good. My final answer would be 91.3 inches cubed. That is how I'd round this to the nearest tenth. Our final question. Find the volume of a pyramid with a square base where the side length of the base is 6.1 And the height of the pyramid is 4.7 meters. Round your answer to the nearest tenth of a cubic meter. So again, I'm dealing with a pyramid. It has a square base. The side length of that base is 6.1, so I'm saying it's a square. We know all the side lengths of a square are congruent. And the height of the pyramid is 4.7. So the first thing we're going to do is we're going to rewrite our formula. V equals 1/3 BH. We know the area formula for a square is just side squared. So I'm going to make that substitution for B. And now we know our side length of that square is 6.1. So I'm going to do 1/3 times 6.1 squared times the height of the pyramid, which is 4.7. When I type that into my calculator, I get 58.29566 repeating. So if I want to round this to the nearest tenth, how would I do it? Very good. My final answer would be 58.3 meters cubed. Perfect. And that's it for today. If you have any questions, please email myself or Miss Colorundo. Have a great day, ladies.